Hello and welcome back to our second lecture for Unit 8. This is on how we can use principles to order the various geologic events that have occurred in Earth history. So to do this, we need to familiarize ourselves with one of two different styles or methods of dating. There are two ways in which geologists determine the geologic order of events, the first of which is relative dating. This is how old a rock is compared to the surrounding rocks. Are the rocks younger or older compared to the surrounding rocks? The second type is absolute dating, actually getting a number of years since that rock, mineral, or fossil had been formed. In this lecture, we're really going to focus on the relative dating principles that are needed to determine whether a rock is older or younger. In a later lecture, we'll focus on the absolute dating principles. So, what are the principles that you need to know for relative age dating? There are three that I want you to pay close attention to. Those are the principle of original horizontality, principle of superposition, and the principles of cross-cutting relationships. We're going to talk about each of these in detail. So, original horizontality. Basically, what original horizontality suggests is that when sedimentary layers are deposited, that often they are deposited horizontally in the environment. And we remember this from our journey to create a sedimentary rock. Remember how once sediment is created, it is transported towards the basin where it is deposited into the location where it will be transformed or lithified into a sedimentary rock. Notice how this body of sediment here, this tannish yellow color, forms a very horizontal body of rock. It does have a bit of an angle to it, but if we follow it to the right and left, we can see that it is largely horizontal on the landscape. Here's an example of some horizontal layers of sediment that could have been deposited in an environment such as this. Now, we take that as the assumption that this is how the rocks started. There are several tests that geologists can use to make sure of that, but in general, it tends to be true. So when these rocks are lying flat, we say that nothing has happened to them. However, once we begin to notice rocks that are tilted, folded, or faulted, we can then infer that those processes that tilted, folded, or faulted the rocks must have come later, that the rocks were originally undisturbed and flat-lying, such as these ones here. Here is some parallel bedding of the different layers. Now, once we see these layers over here, these are tilted at an angle. So what we can infer is that they were originally deposited horizontally, but sometime later, some process, some tectonic force caused them to tilt to the side. So we have those two different events, the deposition of sediment creating those parallel layers, and then the topographic or tectonic process that tilted those layers in another direction. The second principle is the principle of superposition. This principle is like those of a layer for baking the layers of a cake. You start on the bottom and you work your way up. The law or the principle of superposition basically says that an undisturbed sequence of sedimentary rocks will begin with the oldest layers on the bottom, and as you go upwards, you will get younger and younger layers. So the layers that are on the bottom are old, and the layers that are above are younger. This is pretty simple when you have only 3 layers to work with, but it can get pretty complicated, and there can be dozens or even hundreds of layers that you have to keep track of. If this principle wasn't available, it would be very difficult to tell their relative order from one another. The third type of principle is that of cross-cutting relationships. This one is going to have a variety of scenarios that we're going to talk about. First is the intrusion variety. Remember, an intrusion is magma moving through rock, breaking through or cutting through pre-existing rock. So we can take this red sandstone here, well, it's just labeled as rock A. At one point, this rock was once whole. It was unbroken, and that would be time period A or unit A. At a later time, unit B, this magma came through and broke and created this layer in between them. This was unit B. We focused here on the cross-cutting relationship because A had to have existed whole before B arrived. A existed and then B came through and cut through the rock layer A. This also happens with faults. Faults can also act to break rock, creating cutting relationships. So here we have some sedimentary layers that are laid down flat or close to it. The faulting that is occurring is shown here, where we see some separation and sliding of the various layers next to one another. Sort of a movement in the down direction. So we have a normal fault here. We might ask ourselves, which came first, the sedimentary layers or the tectonic fault? Based upon the principle of cross-cutting relationships, the rock layers must have existed first before they could have been cut by the fault. So as a general sort of summary of this principle is that whatever cuts is younger. The thing that is cut is always going to be older. Something has to have existed first before it can be cut by a fault or an intrusion. So we want to keep that in order as well. So now that we have these three different principles, we're going to use them to unravel geological histories that might present themselves on our planet. So here is a geologic puzzle, a geologic history, and we can actually use the principles that we just talked about to unravel them and make sense of the precise order of events. So there are four different features here. First, we have A. A is a series of sedimentary layers that have been folded. That folding, that tectonic folding, is layer B or unit B. Then we have a magmatic intrusion, this magma chamber with this intrusion coming through. And then we have unit D, which is a fault that is moving in a normal fault direction. So what is the precise order of the events that formed this collection of rocks? So let's order the history together. First, we can focus on rock layers A. These layers must have been horizontal in the beginning based upon the principle of original horizontality. We also see that the rock layers have been folded, and so we can assume that that folding came later. It had to have come later because the rocks layers must have existed first. The other thing that we can look at is the magma intrusion. The magma intrusion shown here cuts across the sedimentary layers. Remember, anything that cuts is younger. It comes later. The things that are cut are older. So the sedimentary layers are being cut by the magma intrusion. So those layers must have come first. Similarly, the unit D, this tectonic fault, cuts through the sedimentary layers. And so that fault must have come later, and the layers must have come first. So first is the laying down of these various sedimentary units in unit A. Next, we have the magma intrusion. Notice how the magma intrusion is not folded. This means that the magma intrusion must be younger and the folding must be older. If it was the other way around, we would actually see the magma intrusion fold with the sedimentary layers. So the next unit is unit B, the folding. Finally, we have unit D, which is the fault. the fault cuts across all of the sedimentary layers, and it cuts across the layer or magma intrusion C. Also, this fault is not folded, and so it is also, we can also tell that it is coming last in this order. So our order is A, B, C, and D. The sedimentary layers were laid down first, then they were folded by the tectonic processes. At some time later, a magma intrusion came through and broke through those sedimentary layers that were folded. And then finally, a fault D came through and broke through the sedimentary layers and this magma intrusion to be the last unit in this history. So this is just sort of a visualization of that history. We have those sedimentary layers being deposited first, then tectonic forces fold those layers up. At some time later, this magma intrusion comes up and cuts through the sedimentary layers. And then finally, we have the folding of those layers and the cutting, or sorry, the faulting of those layers and the faulting of the magma intrusion. Okay, you now have some of the information you need to order the events. In the next lecture, we're going to talk about unconformities, which do show up in the quiz. So be sure to watch the next lecture before you work on the geologic puzzles in your quiz.